the Polk Power Station, about 13 miles south of Mulberry in Central Florida. And what we do here is use coal, a low-cost solid fuel, turn it into a gas, and then use that gas in the combustion turbine to make power. Integrated gasification combined cycle technology is what we use here at Polk. There are two main components to that. The combined cycle part of the process is a typical system that's used widely in power generation. It's called combined cycle because it combines a combustion turbine with a steam turbine. The waste heat from the combustion turbine, which has its own generator, is not wasted but used to generate steam to generate additional power in the steam turbine, hence the term combined cycle. Very efficient system. It's got very high efficiency, and we use that as the power, what we call the power block part of the process. That power block can be fueled with either two fuels, distillate oil, which we call our backup fuel, but synthesis gas, which is our primary fuel. Now the process of making that synthesis gas is gasification, and that's the front end of the process. So there we start with two flow streams. We want to use fuel, which in our case is coal or petroleum coke. We grind that fuel, mix it with water, and turn it into a slurry. That slurry is about the consistency of a milkshake, say. It's a good analogy. And we actually pump that coal water slurry into a gasifier. The other stream that goes into the gasifier is pure oxygen, and those are injected into the gasifier vessel at about 400 pounds per square inch, fairly high pressure. The gasifier vessel is really pretty simple. It's just a pressure vessel lined with refractory that's been preheated to about 2,500 degrees Fahrenheit. When you inject that coal slurry and oxygen, it begins to react. Some would say burn. The technical term is gasify. The sulfur that comes in with our coal, we actually remove that from the syngas, turn it into sulfuric acid, and we sell that in the local market. So it's a win-win situation for the company and our customers. The mineral matter that comes in with coal can also be sold and used in the manufacture of cement. So we have very little, essentially no solid waste byproduct from this plant. One of the advantages of gasification is that it's capable of removing CO2 from the fuel gas before it's used in the combustion turbine. With some modifications, we can achieve, the technology can achieve about 90% removal of carbon dioxide. So what we end up with then is a synthesis gas or a fuel gas that's been cleaned of its particulate matter and sulfur. It's burned in a combustion turbine in such a way that it produces low emissions of nitrogen. So you started out with coal, which has historically been known as a dirty fuel, but with this process becomes a very clean fuel gas and produces extremely low emissions. Well, the technology does have the capability to capture CO2. We're very comfortable with that. In order to ensure that it doesn't become a pollutant in the atmosphere, you've got to store it or sequester it in some way. And the most commonly thought of way to do that is by deep saline aquifer injection. We've done a study with a local university here, University of South Florida, and it looks like there's a deep saline aquifer almost a mile beneath our feet here that has a confining layer above it that would be suitable to accept a stream of CO2 that we capture from the process. Sequestration is seen as the solution for CO2 from fossil fuel power plants. Polk Power Station was the result of a number of efforts that came together in the early 1990s. The opportunity and the intent there was to demonstrate at a large scale this clean coal integrated gasification combined cycle system. The reliability of IGCC is good, and in fact, if you consider that an IGCC can run on either syngas from coal or a backup fuel, the overall reliability of these plants is excellent, over 95%. We've also demonstrated that the IGCC technology is capable of using biomass. We've done some testing on our existing unit. Generally, biomass, because it's got lower energy density, turns out to be a slightly more expensive fuel to use. And that was the case we found to be during testing early on. But it can be used. Should the economics change, the relative economics of biomass versus coal or petroleum coke, or should there be a requirement for a renewable energy standard? These are options that can be solved with additional use of biomass in an IGCC. I think Polk is noteworthy in that we've been using integrated gasification combined cycle technology for over 10 years here. We've actually produced more power from coal-derived syngas than any other facility in the world. Again, a number of technical advances have been produced here, and those lessons learned will be integrated into the next generation of plants. So the work here has been beneficial for our customers, but it will also be beneficial for the industry as a whole as we move forward with more of these plants.